This segment of our course on compressors deals with valves and valve unloaders. The heavy-duty reciprocating compressor that we've been studying usually uses a form of reed plate valve. This is a cutaway of a typical type of reed plate valve now in use. This is the valve seat. And this is the stop plate. The two may be held together with through bolts and nuts. As you can see, this particular valve has a lock nut with a cotter key through it, and the bolt. Between the valve seat and the stop plate is the reed plate, or ring. It is mounted on springs which are recessed in the stop plate. The reed plate may be in the form of one or more rings, or there could be rings connected by webs. Whatever the case, the reed plate, or rings, are held lightly against the valve seat by the springs. To open the valve, the air or gas must overcome the pressure of the gas on the other side of the plate, and the light tension of the spring. When it does, the valve will open and allow the gas to flow through. When the pressure is equal on both sides of the plate, the springs will keep the reed plate shut against the valve seat. Since both the suction and the discharge valves on a reciprocating compressor could be identical, you must be very careful to see that they are installed correctly. To check the suction valve for proper installation, push the reed plate in the valve toward the cylinder. If this action opens the valve, your installation is correct. A discharge valve is properly installed when you can open it by pushing the reed plate away from the cylinder. Remember, it is very important that the valves are installed correctly. If you installed a discharge valve backwards by mistake, the pressure could build up and cause the cylinder to blow up. Not a pleasant thought. If a valve you have installed has a tendency to slam or flutter, you can correct the problem by changing the tension on the springs. If it slams shut too hard, the springs may be too strong. If the reed plate tends to flutter, the springs may not be strong enough. In this illustration, you can see the entire valve assembly as it is mounted in a typical reciprocating compressor. We'll begin with the valve port in the compressor cylinder, like this. The valve itself is seated on a gasket in the machined recess in the valve port hole of the cylinder. The next problem is holding the valve in position. And this is done with this valve yoke placed on top of the valve. Your next step will be to tighten this set screw in the yoke against the valve cylinder wall. It should not be tightened too tight, or it could force the yoke out of position from its seat on top of the valve. Once the set screw is tight, install the valve cover on top of the valve port. This jam screw in the center of the cover should be retracted when this is done. Tighten the bolts in the valve cover until it is seated firmly and securely in place. Your next step would be to tighten the jam screw down. By doing this, you are jamming the yoke down against the valve, which is seated in the machined recess of the valve port. The valve is now secure in place. Remember that the illustration we are showing you is just one example. You will undoubtedly encounter other basic types of valve assemblies during your work on reciprocating compressors in the future. Now that you've seen what a basic valve looks like and how it operates, we want to mention one more part related to valves. Let's suppose that a suction valve sticks in the open position as the piston begins its compression stroke. If this happens, the compressor would force the air back out through the suction side. This means that no gas or air would be forced through the discharge valves, and there would be no load on the driver. This can be very useful during startup and shutdown of the compressor driver. This is true because it is always best to start or stop a driver without a load. Since a need was proven for it, engineers developed a successful valve unloader. It operates by depressing the reed plate in the suction valve until it opens. This is accomplished with a hand wheel, like this. Or it can be done automatically by air pressure, or some other means. The only requirement is that pressure be exerted against the reed plate in the suction valve until it opens, and is held there. Once this is done, the gas is not compressed, but flows back into the suction gas jacket. This takes the load off the compressor. In some cases, on multi-valve compressors, valve unloading is used to vary the capacity of the compressor. However, unloading should only be done on one end at a time. Unloading both ends of the same cylinder in a double-acting compressor will usually result in a badly overheated cylinder. Here are the basic rules to keep in mind with regard to the unloading of valves. Number 1. Unload only one end of a cylinder at a time. Number 2. To reduce the pressure and temperature at the packing, make sure you unload the head end. Remember, unloading valves always decreases the horsepower required to run a compressor. If you'll remember, clearance pockets, described in the last segment, accomplished much the same objective. In fact, there are many cases where clearance pockets and valve unloaders are used at the same time to vary the horsepower of a reciprocating compressor. Using them in conjunction gives you a wide variety of compressor capacities to work with. We have some questions for you now on valves and valve unloading. You'll find them in exercise number 4 of your workbook.